So this one is index of. It's a pretty common array operation. We do this a lot. We get a certain value. We get an array and then we get a certain value and we're trying to understand what the position of that value is in the array. What is the index of the value? So in this case, we get an array with 1, 2, 3 in the array and the value we're searching for is 2. So the expected position or the position of 2 is 1 because there's 0 index in arrays. So 0 and then 1 is the position in the array of the value 2. And the way index of usually works and the way it'll work here is it will return the first thing that it matches. So we don't have to worry about returning like an array of all of the positions that match that value. And we see here, same thing. Let's, and also because this is not just like JavaScript, this is TypeScript and we're dealing with type values, we can look for things like any. This is a tricky one. So this is an array, a type array that, or really a tuple that has string and then the literal value 1 and then number, the literal string a, and then the last thing is any, and we're looking for the index of it, and it's 4. 1, 0, 1, 2, 3, 4. Okay, where would you guys start on something like this?
So I think we need an accumulator counter like we had before.
Great, I'll set it up. So if anybody hasn't seen in the flattens videos and what was it, greater than, in a couple of the videos before that we've done together, we use a counter. So we'll say count extends one array equals extend with an S, extends one array equals empty array to begin. So this is just an array of ones and we're using them to count. All right, where would we go from here? Would you like some generic constraints here too?
Yeah, I think so.
Thought so. All right. So, and of course you can be anything, so there's no constraints there.
Yeah, I think we need to infer head and tail again.
Mm-hmm.
And then check whether head is u.
Mm-hmm.
And if that's the case, then we would return count, the length of count.
All right. So can we do the false case though, just because it's in front of us? So if t is not an array, or I'm sorry, if t doesn't have values to give,
it's -1.
Exactly, -1, because we're all out of values. There's nothing left. We've recursed through that could happen if there's no tail, right? There's nothing else here, or an empty array would also return -1. So I think an empty array is probably in one. Oh, there's not a test for an empty array. Well, anyway, this is the case it hit. All right. So for this part, I'm going to help you out a little bit. It is extraordinarily difficult to do an equality check for types in TypeScript that actually works because you have this thing that you have to contend with where you have types like any and never and unknown. Never is like the topmost type. Any and up. I mean, it's very difficult to do that assertion. And it's debatably cheating, but there really is only really one way to do this. You can use this equal utility that's available to the type challenges because all of the tests use it. I don't want to go too much into depth about what this guy really looks like. Let's put this here, but it's abusing a thing with generics and basically saying, does t extend y, does t extend x, but x and y are the two values we passed in. It works. I don't want to explain why it works right now, but we can check that equality that you were asking for here. We can check head and u. And the way that the syntax forces us is we have to say true.
I would be naive enough to just type like
head extends u.
Extends u, but that somehow won't work.
It won't work because, well, I'll show you. Let's do that and then we'll come back to it. Okay, so here, what are we going to do?
Then we would return count length. Count length.
Yeah.
The length count,
Exactly. And then in this position, we have to recurse, right?
Yeah.
So index of, and then what should we pass to index of?
Tail. U is the same. And count
we have
would
to increment
be
the counter. Yep. Not, man.
Count the queuing stat.
1, yeah. Exactly. Great.
Yeah.
So if we look, some of these pass, like it definitely works here for these numbers, these literal values, but check this one out. It tells us the answer is 1. The index of number is 1.
Right. Because
And the reason
one
is that, like, well, I mean, let's look at what would happen in that case. We would say, does 1, there's going to be some case where it says, does 1 extend number? Well, 1 does extend number.
Yeah.
But it's not the same.
But it's not the same. Right.
Yeah,
so that's why we need to say, we need to have that line here where we say, you know, is head and you, are head and you equal, extend, then do we, and then the way to make it like a Boolean operation is to say extends true. And then it works. Yeah, everyone works here. So we have the right values. Cool.
Yeah.
Awesome.
Cool.
So I found very few alternatives for this one, but I did find a nope. We haven't seen a nope, the three of us yet together, but sometimes I look through the examples online of people trying to solve this, and I see a recurring theme. Sometimes that's because the challenges didn't have like those tests, and so maybe this used to pass. I think a lot of times that's what it is, but I wanted to show it because I thought it was kind of interesting. So the way this one works is it has this shift thing going on here, and for IndexOf, we have a accumulator that, like just like we had before, we could call it count. Here's a refactor, fun one. We could just make it a 1 array. So this is exactly the same like we had before. So if it's an empty array, we return -1. Great. But here, they're accessing the first value. Instead of inferring, they're accessing the first value literally of the array. And this fails because of the same reason like we saw before, because well, this is going to say 1 just like we saw before as the index, because number matches on 1. It doesn't work. So anyway, just thought I would show that. This is a slightly different approach. It uses this shift thing here, and it passes values in like that. This is the recursive step here. So I just thought it was interesting. But yeah, that's IndexOf.